Good day, everyone. This is Professor Friday from Macomb Community College coming at you one more time. I've been grading a Pre-Calculus 2 test recently. Pre-Calculus 2 is our college trigonometry course, and it deals a lot with the Pythagorean theorem, and this came up recently on a test on which the students were not allowed to use a calculator. So I was posed the question, how do I simplify 29 squared minus 21 squared all underneath the square root without a calculator? Well, I could think of 4 different ways off the top of my head. I suppose that we should probably go with the most straightforward, lowest tech first. So, by low tech, of course, I mean, let's do 29 squared. Well, that'd be 29 times 29. And then we do the classical approach with it. We say, multiply 9 times 9, we get 1. Carry the 8 over. 2 times 9 is 18. Plus 8, we get a 26. Then we're done with the 9. We do 9 times 2, that'd be 18. Carry the 1 over, 2 times 2 is 1, and we get a 5. So then we add them up, it'd be 1, 6, and 8, we get 14. Carry the 1, 841. So then 21 squared, we do the same thing. Thankfully 2 and 1 are a little bit nicer to deal with. 2 and a 1, and a 420, and then we laugh a little because we said 420, and we get 441. So from there, 841 minus 441 would be the next operation that we're supposed to do. So it'd be 841 minus 441, and that's going to take us down to 400. Then we would take the square root of that, and there are all sorts of different ways to do that, but I'd say the easiest one would be to recognize that 400 is simply 20 times 20. So there you go. I'm fairly certain we've also done an example in class where we use the 20, 21, 29 right triangle, but that's neither here nor there. So this would probably be the most straightforward, this is what I learned in my arithmetic class kind of way to multiply these numbers. Again, very low tech, not the most efficient use of our time. So with that in mind, we're going to teach you some other techniques today. First one is my absolute favorite 4-letter F word, which would be FOIL. Most of you probably, well, most of you know FOIL. This is what you get when you're trying to multiply 2 binomials together, a plus b times c plus d, and you get a first term, which comes from the a times c. So the 4 terms would be these 2 guys right here, F, and then an O, and then I, and L. So the 4 terms in the order listed would be a times c, plus a times d, plus b times c, plus b times d. This is known as FOIL. And one of the biggest mistakes that we as educators make in our algebra classes is that we only teach our students how to do this with variables. Well, variables simply represent numbers, so if we could do the same kind of thing with something like, oh, I don't know, 21 squared, we just said that this is 21 times 21, if we can convince our students that we could express this as 20 plus 1 times 20 plus 1, I think we'd be in pretty good shape. So, let's do it again. Let's FOIL. Then we've got, 20 times 20, 20 times 1, 1 times 20, and 1 times 1. All of these are much more manageable than any of the other things that we do. This is technically what you're doing when you do 2-place multiplication. It really just is the distributive property, but this will help really emphasize it. So we got the 20 times 20. That's 2 times 2 and 10 times 10. That's 400. Outside is 20 times 1. Inside is 20 times 1. Last is 1 times 1. So, as far as the hundreds are concerned, we got 400. For the tens place, we got a 20 and a 20. And for the ones place, we got a 1. We got 441 again. Now for the 29 squared, again, this is supposed to be 29 times 29. If we took the same approach, we would be doing 20 plus 9 times 20 plus 9. And quite frankly, I don't like that approach. I don't like it at all. So much so, I'm going to cross it out. That's because 9 is not a very pleasant number to deal with. It involves a lot of carrying when we multiply. So rather than going 20 plus 9, I'm actually going to go with 30 minus 1 and 30 minus 1. This will be a little bit nicer for us. Same thing, first, 30 times 30. That's a 3 times 3 and a 10 times a 10. That's 900. 30 times minus 1 will be minus 30. Negative 1 times 30 will be minus 30, and negative 1 times 1 will be plus 1. So the 30 and the 30, that makes 60. Subtracting 60 from the 900 will give us an 840, and we still have the 1 tagged on at the end. So we still get our 841 and our 441. I think both of these, they work pretty nicely. Let's get to a more advanced technique. Again, all that we're doing up here is algebra. So I'm going to ask you to recall with me one more formula, which is the difference of squares formula. Difference of squares is how we factor differences of squares. And like I like to say at parties, difference of squares factors into binomial conjugates, which is why I don't go to many parties. A squared minus b squared is equal to a minus b times a plus b. Well, why is that relevant to what we're doing right here? Well, because underneath the radical, we had a 29 squared minus a 21 squared. Again, it doesn't ever occur to our students frequently enough that we can factor this the same way that we would factor it as if it were variables. According to our formula, this should be 29 minus 21 times 29 plus 21. Then we'd have 8 times 50. Now, at this point, if you can do a 5 times 8 and get 40, you are done with this problem. We didn't have to square each of these individually, we just had to factor it like it was a difference of squares. Again, the folly of our education is that we talk about how to do this with variables, but we don't actually talk about how to do it with real numbers. This is why so many mathematicians can do these arithmetic acrobatic techniques and fly through the air and leaving our students behind. Students, my plea to you is, if you can do this with variables, it means you can do it with numbers. Try it sometime. It's good for you.